Hi everybody, I hope you are doing well. This is your next video in our series of videos on probability to help us wrap up the end of the school year here. This one today is on a topic called mutually exclusive. And I'm going to tell you what that means in a second. And then more importantly, this thing called the addition rule. So just like normal in all these other videos that I've made, I have the slides that I would normally go over in class on the left side of the screen, and then the notes that you would use to follow along with me on the right side of my screen. So I'm going to be writing on the right side of my screen. So follow along with me here. All right. So like I said, this topic here today is on two things in probability, two events that are called mutually exclusive, and then with the addition rule. So typically you're going to use this idea when you see the word or in a probability problem. So if you remember back 2 lessons ago, I think it was, that one of them that Miss L did, where she was telling you about the difference between and or in probability, right? So and is the intersection of two things, and it's typically represented with this symbol. It's typically represented with this symbol. It looks like an upside down U. The way that I like to think of it is it kind of looks like an A, but without the line through the middle. And then she also told you about the symbol for or, which is just a regular U. Okay. So what we're going to be focusing on today is mostly this idea, this or idea. So the first thing I'm going to tell you about today is this idea of two things being mutually exclusive. Basically, that just means two events or two things that cannot happen at the same time. You're going to hear me use playing cards, like a deck of cards, a lot in this video especially. To talk about these ideas. So if you think about a deck of cards, a card, for example, can't be both a king and a queen at the same time. That's not possible. But a card can be both a queen and a heart at the same time, for example. So like I said, today we're mostly going to be talking about this word or. So if you see that word or, you're either dealing with overlapping events. So that would be like the queen, a card being both a queen and a heart at the same time. Okay? Or you're dealing with mutually exclusive events. Okay, those are like the king and the queen, right? So a card can't be both a king and a queen at the same time. And I know my handwriting on the right is a little bit difficult to see, probably a little difficult to read. So I would follow along here on the left side of the screen as well. Okay, so let's jump into this a little bit more. Right? So mutually exclusive events. Okay, so I'm here on this side now. So mutually exclusive events cannot happen at the same time. And I'm going to abbreviate a little bit in my notes on the right side here. So those are two things that cannot happen at the same time. So what that means is that the probability of one of those things happening doesn't affect the probability of the other one happening. Okay, so probability of one event doesn't affect the probability of the second. Okay, so the way that you want to think about mutually exclusive is if you think back to like a Venn diagram, that would be two circles. Like normally in a Venn diagram, they're together like this, but they would be completely separate. Mutually exclusive events have absolutely no overlap at all. They can't, it's things that can't share anyone in common. Okay, so when you were doing Venn diagram stuff with Miss L, you remember when you were trying to find or probabilities, that would be like this thing or this thing would be everything inside the circles. Okay. And you typically, to figure out what those values are, you would add everything up that's inside the Venn diagram, like all the numbers. Okay. So it's the same thing for mutually exclusive events. All you have to do to figure out the probability, the or probability of mutually exclusive events is add the probabilities together. And I'm going to do an example here for you in a second. Okay, so all you have to do is add the probabilities together. Really, really simple. Okay, so let's look at an example here. Okay, so we're going to go back to our deck of cards. So here I am, I have my deck of cards, and I want to figure out what the probability is that I choose either a king or a queen out of the deck, right? So if my deck is shuffled and I just want to pull one card off the top, what's the probability that the card that I pull is either a king or a queen? Okay, so we need to think about, okay, how many kings are there and how many queens are there, right? So what I'm trying to find in probability notation is the probability of king or queen. Okay, and I know I have it as A and B over here, but I'm going to write it as king and queen, so K and Q for you on the right side. Okay, so all I need to do is add those probabilities together. So I need to add the probability that I get a king plus the probability that I get a queen. Okay, so in the deck, there's 4 out of those 52 cards. Whoops, I'm getting messages as I go here. Okay, so I'm either... So I get, there's 4 kings out of the 52 cards. Okay, and then there's also 4 queens out of the 52 cards. So if I want to figure out what the probability that I get either one of those, I need to add these two together. So remember, when you add fractions, that you don't add the denominators, you're just adding the numerators. So 4 plus 4 is 8. So I have 8 out of 52. And then it's usually a good idea to reduce your fraction. So meaning I want to try to find the smallest possible version of this fraction, right? So I know that 4 goes evenly into both 8 and 52. It's a factor of both 8 and 52. So when I reduce that, if you see, I have it there worked out for you on the left side. So 8 divided by 4 is 2, and 52 divided by 4 is 13. So I have a 2 out of 13 shot here of picking either a king or a queen out of my deck of cards. All right. So give me just a second, because I need to pause the video so that I can get to the next part and erase my screen and move my screen up a little bit. So I'll see you in just a second. Okay. So, remember in the previous example that I did for you just now, was on 2 events that are mutually exclusive. So those are 2 things that can't happen at once. So just to summarize what we did, all you have to do is add those 2 events together, the probabilities of those events together, because there's no overlap at all. Okay. But we're going to look at, for the rest of the time, in this video, is overlapping events. So those are 2 things that are 2 events that may have people or things in common, right? So that's more like your typical Venn diagram, where the 2 circles literally overlap and then they have a section in the middle that they share. Okay. So the problem with dealing with overlapping events is if you just add the total together, so say like the total in one circle and then the total in the other circle, there's going to be a section that you count twice, and that's the section in the middle that they share. So we can't just add, we have to add and subtract for overlapping events, okay, which is what I have up here at the top. So I'm going to show you what I mean by that, Okay, again, using our deck of cards. Okay, so here I'm picking, again, I have my deck, I've shuffled my deck, and I want to figure out what's the probability that I pull a heart card out of the deck or a 2 out of the deck. Okay, so I'm finding this, the probability of that I get a heart or that I get a 2. Okay, again, it's A and B on the left side of the screen, but I'm going to use H and T for heart and 2. Okay, so these two events are overlapping, right? So if we think about a deck of cards, there's one card that'll be included twice if I just add the heart and the 2. So let's think about how many heart cards there are in the deck. So there's the ace, 2, 3, 4, all the way up to a king. So there's 13 heart cards out of 52 total. And then for 2s, there's 4 2s in every deck. Okay, so 4 out of 52. Okay, so if we did what we did in the last example and just add these two together, there's one card that would be counted twice, the 2 of hearts. It's counted here as one of the 4 2s, and it's also counted here as one of the 13 hearts. So since there's one card that they have in common, I have to subtract that card out to get rid of the fact that it's counted twice right here. Okay, so what we're going to do now is do just the same like adding and subtracting that we did with fractions in the last one, right? Same concept. We just have this extra step where we have to subtract. So I have 13 plus 4 is 17. 17 minus 1 is 16. So 16 out of 52 is my fraction. And then again, we do want to try to reduce the fraction. So 4 is the common factor again in this problem. So 16 divided by 4 is 4, and then 52 divided by 4 is 13. So we have a 4 in 13 shot of picking a card out of the deck and saying that it's either a heart or a 2. Now it could be both. It doesn't matter if it's both. That's one of the things about or probabilities. It's different than what you remember about things, the way that the word or works in English, right? When we talk about or, like when you're just saying something to someone, like I'm going to go to this place or this place. What you mean is that you're going to go to only one of them, like one or the other and not both. In probability, it's different, that you can be included in both categories when you're talking about an or probability. The only criteria is that you must be in at least one of those categories. Okay. All right. So, to summarize all of this, this is the really, really important thing and the big takeaway from this video today is this thing called the addition rule. Okay. So if you have two events that are overlapping, then, the or probability, so the probability that one or the other event or both will occur, is the sum. So that means add, right? So the sum of the probabilities of each of those individual events minus the overlap part, the intersection of the two events. So what that means is that you have to add and then subtract. Okay, so you add the two events together and then subtract the probability that both of them happen at the same time. Okay, so again, I want to show you kind of why that is visually, right? So here we have our Venn diagram. So say like this last one, I have my hearts over here and I have my 2s over here, right? So there's 13 total hearts here. And then there's 4. I'm going to put a box around that because that's normally how we notate those, right? If you remember Miss L's lesson, right? The totals typically go outside of the Venn diagram and we put a box around them. Okay. So I can So the hearts, if I'm saying the total hearts, would be all of this, like this whole circle. Okay. And then the total for the twos would be this. It's this whole circle right here. So you can see that where they meet in the middle, right here, is counted twice. Right? It's counted once here in the 13 for the yellow, and it's counted once here in the 4 for the blue. So I have to subtract one of those out so that it's not double counted. Okay. All right. So that is the actual addition rule. Like that's the addition rule. Okay. And the formula for that is this. So the probability of A or B, no matter what, is the probability of A plus the probability of B minus the probability of A and B. Okay. It's really, really similar to this equation up here, right? So this equation is really similar to this equation that we have up here. There's just this addition, this minus A and B, okay? And if you think about that, that does make sense, because when you're talking about a mutually exclusive pair of events, like two events that can't happen at the same time, the probability of A and B, would be 0 in that case because there's no overlap at all. So if you subtract 0, that means that part would just go away, and then you're left with the same equation that you had up here for the mutually exclusive events. Okay, so it's the same type of stuff, right? But this is the one that you want to remember, though. Okay, like this is the really, really, really important one because that's the general equation, right? Like that's what will work every single time, no matter what the problem is. Okay. So I'm going to do one more example for you. Sorry, there's something happening outside my window, if you can hear that. So I'm going to do one more example for you. And then there's some practice problems that you can try on your own if you want. So give me a second. I have to erase my screen. I'll be right back. All right, so let's try one more example together. And then, like I said, you can try these practice problems that are at the bottom of the page if you wish. Okay, so here we are in a class. So in Mr. Pearson's class, there's 12 girls and 15 boys that completed their homework, their math homework. There's 14 girls and 16 boys in the class total. Okay. So the question is, if a student is randomly chosen, what's the probability of choosing a girl or a student who completed their homework? Okay. So I know, again, like I said, they use A and B on the side there, but I'm going to use G for girl and H for homework. So I'm trying to find the probability that I randomly pick a student who's a girl or I pick a student who's completed their homework. Remember that the symbol for or is that upside down U right there. Okay. So I need to add those individual probabilities together. So the probability that I get a girl plus the probability that I pull someone who did their homework minus who they have in common, right? Because if I just count all the girls and I just count all the people that did their homework, I'm going to count some girls twice, right? I'm going to count some students twice, the girls who did their homework, because they fit in both categories. So I need to subtract girl and homework. Remember that the symbol for and is that upside down U. Okay. So let's go through and figure out what these probabilities are. So if we look back, we see that there's 14 girls in the class. Okay. So 14 girls out of, and then I have to figure out how many total people there are in the class. 14 plus 16 is 30. Okay, so there's 30 people total, so that's my denominator. Okay, so that's the probability that I pick a girl at random. Okay, plus then H is how many people did their homework. So if I look back, if I add 12 and 15, that's 27. So 27 students total completed their homework. Okay, so now if we just stop right here, there's some people that I've counted twice, right? And you can see that if you add these together, right? Because 14 plus 27 is bigger than 30. Remember that probabilities have to be between 0 and 1. So I need to subtract out the number of students or the probability of students that I have in common here. So the girls that did their homework was 12. So there's 12 girls that did their homework out of 30. Okay, so I need to add these two together. So 14 plus 27. Okay, and then I need to subtract 12 out. So 14 plus 27 is 41. And then if I subtract 12, I get 29. Okay, so 29 out of 30. And that's my probability. Okay, so there's 5 practice problems underneath here. They do get more difficult as you go through. So 1 is the easiest and 5 is the trickiest. Okay? If you try those problems and you would like the answers or you're curious about that, send me a message and let me know because I'm happy to give you the answers for those. Okay. So again, biggest thing to remember is this guy right up here. That's the addition rule. Okay. So I will see you all in the next one. Okay. Bye.